So hello everyone. In this particular session, I'll be explaining a very simple code which finds the length of any given string. Okay. So first of all, what do you mean by a string? String is nothing but a sequence of characters which are placed in consecutive memory locations, and it is usually terminated with a null character. What is the value of null character? It is nothing but 0. So in this particular code, we'll consider any string, like for example, let us learn about ARM7. This is an example for a string. Okay. Our work is to find the length of the string, or how many number of characters are present in this particular string. Area is nothing but an assembler directive which defines a section of memory to store this particular information. strlen is the name I have used to represent that particular section of memory. Code informs that this particular information is nothing but actual instructions. Read only because we don't want any modification to happen to this particular code during runtime. Entry indicates where exactly the execution starts. The very first label after the assembler directive entry is the location where the execution starts. Now let's understand what exactly is happening here. Okay, LDR R0 comma equal to string. String is again a label here, okay, which is associated with our actual string data whose length is to be calculated. So now the address associated with string is stored in the register R0. Okay, and R0 acts as the pointer to this particular string. Next, we have stored a value 0 in the register R1. R1 is our actual counter in which we are storing our final result, that is the length of this particular string. We are using LDRB, that is we are trying to load a byte of data from the address stored in this particular register R0. That is, we are just loading 1 byte of data from this particular string. Why are we loading 1 byte of data? The reason for that is if we consider individual characters belonging to this particular string, like for example L, E, T, space, U, S, etc. Each of this character will take 1 byte of memory. Okay, so if I'm loading 1 byte of data at a time, I'm actually loading 1 character at a time and I'm placing it in the register R2. Okay, that is what is happening here, and this comma #1 is because I want to increment the address of R0, which is initially pointing at this particular location, so that it points to the very next location. So that is what is happening here. Load the first data, place it in R2 and increment R0 address so that it can point to the next character. Okay, so this is the most important instruction here, where we are comparing the character that we have extracted and placed in register R2 with a value 0. Why is this comparison done? We actually know that a given string has terminated by checking if the given character is actually equivalent to null character. Null character has a value 0, as you can see here. Okay, as soon as the 0 is detected, we get to know that we have reached the end of the string. So our purpose or our motive here is to check whether we have already reached the null character, and if it is true, we are branching to done. If it is not true, we are incrementing the value of R1. Now if we consider this particular string, R0 will be pointing at the very first character here. Let's consider the same character L. We get to know that its ASCII value is 4C. So this will not be equal to 0, because of which this particular branch won't happen. As you can notice here, it is branch if equal to done. Equal to means it is checking the Z flag. If Z is equal to 1, we are branching to done, indicating all checkings are done and we have already reached the end of the string. Okay, but because in this particular case the values are not equal, comparison performs subtraction. So 4c minus 0 will be 4c, it will not be equal to 0, because of which z here will be set as 0, and hence this branch will not occur. Instead r1 is incremented. Initially it is 0, after this instruction r1 becomes equal to 1, and we are branching back to loop. So this loop continues until we have reached the end of the string. As soon as null character is seen, this comparison will generate a value 0, and hence branch will occur to done. Now some of you might have this confusion, what if in the string itself there is something like, what will happen in this particular case if I used 0 as a part of the string? Will it consider only till here as the length of the string, or it will consider the entire string? It will consider the entire string, because if you consider 0 inside the inverted comma, which makes it part of this particular string, its ASCII value is actually 30 and not 0. Okay, this is one of the things which confuse people. Okay, so because of which there is a clear distinction between null character that you see here and 0 as a part of the string. Okay, so we can just try that also later on. Align here ensures that the next whatever instructions are there, they are word aligned. Now since we know what is happening here, let's see how exactly it works. But before that, let us count the total number of characters present here. These are 3 characters. There is a space here, so plus 1. Here we have 2 characters. Here again space 1. These are 5 characters. Then again a space. These are again 5 characters. Again a space. And these are 4 characters here. Okay, so 23. We have total 23 characters. This in hex will be nothing but 17. Okay, so we are expecting a result 17 to be stored in register R1. Okay, now let's continue here. Okay, so at first let's load the address of string into the register R0, which is 20. So I'll go to my memory window and see how the data is stored. If you see here at the location 20, these are the values stored. How do you know this is the actual statement that we see here? If I come here, okay, and right click and convert to ASCII, I can see my actual data here, right? Okay, while if I want to see the numeric values, then I'll have to retain it in unsigned character, and here our counter R1 is loaded with the value 0, and next we'll be loading the very first byte, okay, into register R2. This is nothing but our letter L. Okay, now let's see that happening. Yes, we have loaded it and we are performing comparison. Okay, so comparison will update our CPSR conditional flags, as you can expect. Right from the very first character until we reach the end here till ARM7, okay, you will not find any character having a value 0, as you can see here. Okay, 0 is seen after 37, that is at this particular position, which is the value for our null character. Now because of that, okay, this branch won't happen and R1 is incremented. So you can see R1 being 1 because the first character is counted now. Okay, and this continues, okay, for all the next characters until the very last character is considered. Okay, so here also comparison is done, and once the last value 7 is considered, the next character to be encountered is 0, okay, or the null character. So as soon as that is encountered, we branch to done. Okay, So as you can see here, a value 17 is stored in register R1 to indicate the length of this particular string to be 17 in hexadecimal or 23 in decimal. Now let's see, will adding a 0 here, okay, will cause any problem to our code. As you can see here, the exact statement that we have written here is seen in the memory. Okay, now since we know it is stored properly, okay, so let's come back here and check whether our code will work properly for this particular string also. Before that, let us check what should be the total number of characters here. 30. So an answer 1e in hex should be seen if this particular code works properly. Okay, so let's see if that happens or not. Let me run this code continuously and see what exactly is the output. As you can see here, 1e is the answer seen, or the length of this particular string. Okay, so that's all.